Welcome to day 9 of C programming. Today we are covering an important concept structure and unions. Why is this topic so critical? Because real world programs deal with complex data and primitive types like int, float, or char just are not enough. With the structure, we can combine multiple data types into a single unit. With unions, we can conserve memory by reusing the same memory space for different purposes. From student records, employees databases to hardware drives, these are fundamental skills that every C programmer must master. Defining using structure and union. Here, what we'll accomplish in today's session. Understand structure and unions, how they are declared and how they are behaved differently. Define and use struct with code example and input-output operations. Work with arrays and nested structures, allowing a multi-recorded system. Learn about unions, how they are conserved memory and where they is useful. This will give to the skills to write and real-world C programs like student management systems, simple databases, or embedded applications. What is a structure? A structure is a user-defined data type in C that lets you group variables of different types under one name. Here, one example is struct student, open the bracket, int id, char name 50, float marks, close the bracket. Instead of using separate array for IDs, names, and marks, we put all of them into one unit struct student. This is extremely helpful in organizing complex data. Think of it as creating your own custom data types that matches a real world object. The struct keyword tells the compiler we are creating a new structure. The member are variable of different types. The structure itself does not allocate memory. That happens only when you declare variables of that structure type. Why use structures? Why do you need to structure in C? Let's say if you want to manage details of understood. Without structures, you need three separate arrays for ID, name, and marks. Keeping them aligned would be mess. Let you group related data. Struct students 100. Advantages. Logical grouping of variables improves code readability, supports scalable systems, essential for passing multiple values to functions. Structures are widely used in file handling, databases, simulations, APLS. Declaring structure variables. Once we define a structure, we declare variables like this. Struct student S1, S2, or we can define and declare together. Student struct student, open the bracket, int id, float marks, close the bracket, S1 and S2. Better word, use type def to simplify your code. Type def struct, open the bracket, int id, float marks and close the bracket, student S1 and S2. Defining a structure does not allocate memory. Memory is only allocated when you declare a structure variables. Accessing members of struct. To access or assign a value to structure members, use the dot operator. S1 dot id equal to 101, S1 dot marks equal to 89.5 to print the values. Printf id percentage d marks percentage 2f S1 dot id S1 marks. If we are dealing with the char name 50, we can't do S1 dot name equals to ratio institute use. Script copy S1 dot name ratio. This syntax lets you handle members of your structure just like a regular variables but neatly grouped under one name. Initializing structures. We can initialize a structure at the time of declaration. Struct student S1 equal to 101 John 90.5. The values must follow the same order as in the structure definition. Since C99, we can design initializers. Struct student S1 equals to I dot ID equal to 101 marks equal to 90.5. Rules cannot initialize inside the definition, only assign during declaration of a variable. Must use struct copy for string assignment after declaration. This is useful for quick testing, static data, and default values. Structure example. Let us put it all together in a practical program. It's a one of the example is there. Use struct copy for strings. Use dot operator for access. Structure gives you can clean, readable, and scalable way to manage data. Structure with functions. We can pass structure to function in two ways. By value, void display struct student. By reference, pointer, void modify structure student star s. Passing by value make a copy safe but memory heavy. Passing by pointer allow you to modify the original structure. It's a one of the example is there. Void modify struct student open the bracket marks plus equal to 5. In main function modify the S1. This is greater for dynamic updates. Efficient memory use building reusable functions. Structures and pointers. Pointers make structures more powerful, especially when dealing with dynamic memory or functions. Create a pointer. Struct student p equals to s1. Access memory using the arrow operator. id equals to 101. Print a percentage d. id is short for p.id. Use struct pointer for dynamic memory, malloc, linked list, trees, modifying structure inside functions. This pattern becomes the foundation of data structures and OOPS style code in C++. Arrays of structures. When you want to store multiple records of the same type, you use array of structure. For example, struct student open the bracket into id name 50 float marks. Struct student 3. Now we have space for 3 students. We can assign s0 id equals to 101. Print copy sd name equals Adishwari. S0 dot marks equals to 90.5. Accessing memories works the same, just to use the array index. Array of struct are like tables or rows in a data type. Useful in any program involving list, employees, books, products. We can combine with loops and functions to build mini databases. Looping through array of structures. To work with array of structures, use loop. For loop, int I equal to 0, I greater than 3, I plus plus. Scan of percentage of t, percentage of s, percentage of f. Display using for loop, int I equals to 0, I greater than 3, and I plus plus 1. Print F id percentage d name percentage s marks percentage n. Additional tips: we use sign of s or sign of s0 to determine number of records dynamically. We can pass each struct to a function like display si. Sort students by marks using bubble sort or qsort. This is often our first step toward toward building data types or reports. Array of structure example. Here, complete example. Struct student yes size 2 for loop int I equal to 0, I less than 2, I plus plus 1, open the bracket, printf, enter id, name and marks per n. Scanf percentage d, percentage s, percentage f. Yes, I dot d id, yes I dot name, yes I dot marks. Output loop. For int I equal to 0, I less than 2, I plus plus printf id percentage d name percentage as marks percentage to a per n. Yes I dot id, yes I dot name and I marks. What you can add. Create a function where display struct student. Add filtering. Example students with marks greater than 90. Use file IO to save load records. Struct array are your foundational for file-based system and report generators. Real world use case. Structure are everywhere in real world C program. Let's look at some actually use cases. Students, struct student, open the bracket into ID, char name 54 marks and close the bracket. Employees, struct employees into ID, char name 54 salary. Library systems, struct book, open the bracket into ID, char title 100, char author 50. Used in banking software, innovator apps, hospital system. Structure give a way to model real-world entities and build logic around them. Nested structures. A nested structure is when one structure is a member inside another. Example, struct date, open the bracket, int day, month, year, close the bracket. Struct student, char name 50, struct data. But why use this? To separate a logical groups like data for code reuse. If multiple structure use data. Use cases. A product with a struct data expired. A person with a struct address location. Nesting make your data more hierarchical and cleanly organized. Accessing nested members. To access nested members, use the dot operator twice. S1 dot DOB dot day equal to 12. S1 dot DOB dot month equal to 8. S1 dot DOB dot year equals to 2001. To printf DOB percentage D per percentage D per percentage D. S1 dot DOB dot day. S1 dot DOB dot month. S1 dot DOB dot year with pointers. Struct students p equals to s1 print a percentage d and dob dot day. Why this matter? We will see the syntax oftenly struck like a time stack files and network structs. Example nested structures. Complete example. Struct date. Open the bracket int day, month, year, and struct students. Open the bracket, char name 50, struct data, remove. Int main function, struct student S1, scanner percentage S, percentage D, percentage D. S1 dot name, S1 dot DOB dot day, S1 dot DOB dot month, S1 dot DOB year. Print of name, day, month, and year. Enhancements. While the date, example, for February 30. Use array of student with a nested DOB. Add struct addresses for complete profiles. Nested structures let you scale your program from simple to complex systems. Structure padding and memory. Structure don't always use memory as you expect. That is because of padding. Struct test carry A int B char C. You might think 1 plus 4 plus 1 equal to 6 bytes, but size of struct test might return 12 bytes. Why? Because of alignment, it must start at an address divisible by 4. Padding employment weights are added between members. Solution: reorder members. Struct optimized. Open the bracket into B char A char C. Now the structure may take just 8 bytes. This matters when we are storing millions of records. We use structs in network communication. We working on embedded systems. Introduction to unions. A union is like a structure, but all its members share the same memory space. Union date, open the bracket, int I float f cast string 20. You can assign d dot I equals to 10, then d dot f equals to 3.14. Key facts. Only one memory is valid at a time. Saves memory. We can use same access methods, comma, use union when only one piece of data is needed at a time and memory is limited. Defining a union. Defining a union is like defining a struct. But remember, all members share the same memory. Union data int I float f cast in 20. We can define variables the same way. Union data d1 comma d2. One of the tip is there. Use size of to see how much memory is allocated equal to the size of the largest memory. Avoid using multiple members at once. You will get unexpected values. Unions are often used in hardware control, protocol parishes, and memory critical applications. Accessing union members. Union members are accessed the same way as in structures. Using dot if accessing directly. Using arrow if accessed pointers. But remember, reading from a member that was not the last written can give garbage or corrupted values. To safely use unions, always assign to the members you intend to use track which member is active using an external variable. Avoid reading multiple members in a single operation. Memory layout, structure versus union. Let's break down how memory is allocated in a structure versus union. Union save memory because memories occupy the same space, but you can use one memory at a time. Use the structure when you need all fields. Use the union when you need only one field at a time and want to conserve memory. Key memory concept. Union overwriting. Union overwrite memory. Here is an advanced example. Each write replaces the previous internally. D dot I equals to 100 writes 4 bytes. D dot F equals to 3.14 rewrites those 4 bytes. A string copy writes up to 20 bytes, completely overwriting the memory. You only need one field active at a time. We want to conserve space. You combine with a type flag for safe union design. Summary and review. Let's close by reviewing what we have mastered today. Structures. Group variables of different types used for records, databases, modeling real world objects. Array of structs. Store multiple records. Use loops to read and display. Nested structs. Model hierarchies like date of birth or addresses. Padding impacts memory, recorder members to reduce it. Unions share memory among members only one valid at a time. Used for various types and memory optimizations. Use struct when you need multiple values together. Use unions when you one value is needed at a time. Build a mini student record system using structs Try adding a union for optional fields like email or phone. Quiz discussion. Before we wrap up, let's open the floor to any functions you might have. One thing to think about, we have discussed a structure, but there is another similar concept in C called a union. Here, a discussion prompt, where do you think union would be useful? Hint. Union allow you to store different data types in the same memory locations. They are helpful when memory efficiency is critical, like in embedded system. So if you have scenarios where a variable might hold one of several data types at different times, consider using a union instead of a structure. Structure example, input and output. Let's begin with a simple structure example demonstrating input and output in C. Here we have defined a structure, name a student that contains three fields. An integer ID, a character array name to store the name, and a float marks to store the student marks. This structure helps us group related data types in a single unit, making our program more organized. In this main function, we declare a variable s of type student. We promote the user to enter the student ID, name, and marks. The scanf function is used to take input from the user. Note that we use the address of the operator for each field except for the name array, which is already a pointer. We print the value back using the printf. Example input output would look like this. Input 101 John 89.5. Output ID 101 name John marks 89.50. This example shows how a structure can be used to collect and display related information effectively. Structure with functions. Next, let's look at how to use structures with functions. We define the same student structure as before with ID and marks. Now we have two functions, display and modify. Display means this takes a student structure as input and print the ID and marks. Modify means this takes a pointer to a student and modifies the marks by adding 5. Why use a pointer here? Because when you pass the structure by value as in a display, it's copied, but when you pass a pointer, any change made inside the function affect the original structure. In main, we declare an initialized s1 with id 101 and marks 87.5. First, we call display s1, it prints the original values. Then we call modify s1, this increases the marks by 5. Finally, we can display s1 again and we will see the marks at now 92.5. This demonstrates how structure and function can work together and how pointers enable modification of personal data. Code demo, array of structures. It is a great example of using an array of structure with input output. Adding sorting by marks, adding searching by name, store the records in a file using the fwrite and fread. This is your stepping stone to student report systems, payroll apps, or addresses books. Example nested structures. Here, what a nested structure look like an action. You define one structure like data separately, then use it as a field inside another structure such as student. During output input operations, each nested field is accessed or modified just like regular members, only using dot notations. This technique is helpful when your program is dealing with compound data, meaning each record has a subrecords like content, info, academic scores, locations, etc. Structure padding demo. Structure padding is a automatic addition of unused memory byte between structure memory to satisfy memory alignment requirements. For example, a cat takes 1 byte. An int often requires alignment at 4 bytes. If a char is followed by an int, the compiler may insert 3 bytes of padding to align it. Why it matters: increases the memory usage silently, affects performance in large datasets or arrays, can lead to surprises when using size of. One of the tips: order members from largest to smallest to minimize the padding. Demo for union shared memory. Let's see a union in a action. Union data int I float f char string 20 and close the bracket in main function. Open the bracket union data d dot I equals to 10. Printf d dot I percentage d for n comma d dot I. D dot f equals to 220.5. Printf per, d point f percentage 2f per n d dot f. Then 0 and close the bracket. Only the last assigned member f is valid. Accessing I afterward will show undefined behavior. All members share the same memory. Union size equals to size of the largest members. Use responsible. You must track which member is valid.